Hello everyone, in this video we are going to write down the isomers of C9H20 like C7H16, C8H18. This elemental composition would fit into the general molecular formula CnH2n plus 2 with the n value equal to 9, and therefore all isomers that we are going to write are alkanes. Now to those students who want to do it yourself in writing these isomers, so here is the tip. With the non-N chain, only one isomer is possible, isn't it? With the octane chain, 3 isomers are possible. In total we have 35 isomers. With the heptane chain, 11 isomers are possible, and with the hexane chain, 12 isomers are possible, and with the pentane chain, 8 isomers are possible. So if you want to do it yourself and then come back and verify the answer. I'm not going to tell you the substituents in the case of octane, heptane, hexane and pentane. You try to figure it out and see how you can avoid the redundancy in all the cases. So I'm going to write the isomers one by one, and also I'm going to write down all the IUPAC names. All isomers will be written in bond line notation. Number 1, we are going to write non-N 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the only isomer possible with the 9 carbon chain. Let's move to octane chain 1, 2, 3, 4, 5, 6, 7, 8, and then 1 methyl group at 2 position. This is 2 methyl octane, and then we can also write 3 methyl octane 1, 2, 3, 4, 5, 6, 7, 8, and then 1 methyl group at 3 position. This is 3 methyl octane, and then number 4 we can write 4 methyl octane 1 methyl group at 4th position. So this is 4 methyl octane. We cannot write 5 methyl octane, isn't it? Because if we start numbering from the right hand side 1, 2, 3, 4, that would become 4 methyl octane once again, and therefore we are exhausted with the octane chain. Now let's go to heptane chain. Number 5, heptane chain first 1, 2, 3, 4, 5, 6, 7, 2 methyl groups at 2 position. This is 2, 2 dimethyl heptane. And then number 6, let's move one of the methyl groups at 3rd position 1, 2, 3, 4, 5, 6, 7, 1 methyl group at 2 position, 1 methyl group at 3 position. So this is 2, 3 dimethyl heptane. And then number 7, we can also write 2, 4 dimethyl heptane 1, 2, 3, 4, 5, 6, 7, 1 methyl group at 2 position, 1 methyl group at 4th position. So this is 2, 4 dimethyl heptane. And then number 8, we can also write 2, 5 dimethyl heptane 1, 2, 3, 4, 5, 6, 7, 1 methyl group at 2 position, 1 methyl group at 5th position. This is 2, 5 dimethyl heptane. And then number 9, we can also write 2, 6 dimethyl heptane 1, 2, 3, 4, 5, 6, 7, 1 methyl group at 2 position, 1 methyl group at 6th position. So this is 2, 6 dimethyl heptane. And then number 10, we can't put the methyl group at 7th position. In that case we will be extending the parent chain. Therefore let's move both the methyl groups at 3rd position 1, 2, 3, 4, 5, 6, 7. So this is 3, 3 dimethyl heptane. We wrote 10 isomers so far. Let's move to number 11 1, 2, 3, 4, 5, 6, 7. Let's put 1 methyl group at 3 position, 1 methyl group at 4th position. This is 3, 4 dimethyl heptane. And then number 12, we can also write 3, 5 dimethyl heptane, isn't it? 1, 2, 3, 4, 5, 6, 7. One methyl group at third position, one methyl group at fifth position. So this is 3, 5 dimethyl heptane. And then number 13, we cannot write 3, 6 dimethyl heptane. Why? Because if you number it this way, 1, 2, 3, 4, 5, then it would become 2, 5 dimethyl heptane once again. That's a redundancy. And therefore, now we have to think about the next option. And the next option is moving both the methyl groups to the fourth position. And then number 13, 1, 2, 3, 4, 5, 6, 7. Let's put both the methyl groups at fourth position. That is another isomer. So this is 4, 4 dimethyl heptane. And then number 14, we can write a ethyl heptane, isn't it? We cannot move both the methyl groups to the fifth position. We are going to write ethyl heptane, but when it comes to ethyl heptane, 1, 2, 3, 4, 5, 6, 7, we cannot put the ethyl group at second position because that would extend the parent chain and therefore that is wrong. But we can put the ethyl group at third position. So therefore 3 ethyl heptane is possible. That is one isomer. And then number 15, we can also write 4 ethyl heptane. That is another isomer. 1, 2, 3, 4, 5, 6, 7 ethyl group at fourth position. So this is 4 ethyl heptane. We are exhausted with the heptane chain. We cannot write any more isomer of heptane. Now we are moving to hexane chain. Isomer 16, 1, 2, 3, 4, 5, 6. With the hexane chain, let us first write the isomers with the methyl groups as substituents. Let's put 2 methyl groups at 2 position, 1 methyl group at 3 position. So this is 2, 2, 3 trimethyl hexane. And then number 17, 1, 2, 3, 4, 5, 6. We can also write 2, 2, 4 trimethyl hexane, isn't it? That is another isomer. This is 2, 2, 4 trimethyl hexane. And then we can also write 1, 2, 3, 4, 5, 6, 2, 2, 5 trimethyl hexane. That is another isomer. So this is 2, 2, 5 trimethyl hexane. And then number 19, 1, 2, 3, 4, 5, 6. Let's keep one methyl group at 2 position, but put 2 methyl groups at 3 position. That is another isomer. This is 2, 3, 3 trimethyl hexane. And then number 20, 1, 2, 3, 4, 5, 6. Let's put one methyl group at 2 position, one methyl group at 3 position, and one methyl group at 4th position. This is another isomer. So this is 2, 3, 4 trimethyl hexane. And then number 21, 1, 2, 3, 4, 5, 6. Let's put one methyl group at 2 position, one methyl group at 3 position, and one methyl group at 5th position. That is another isomer. So this is 2, 3, 5 trimethyl hexane. This is definitely not 2, 4, 5 trimethyl hexane. That way of numbering is wrong. And then number 22, 1, 2, 3, 4, 5, 6. Let's keep one methyl group at 2 position and 2 methyl groups at 4th position. If you number it on the other way around, so it becomes 3, 3, 5. That is not the correct way of numbering. The correct way of numbering is left to right. 2, 4, 4. That is correct. And therefore, this is 2, 4, 4 trimethyl hexane. And then number 23, 1, 2, 3, 4, 5, 6. Let's put 2 methyl groups at 3rd position and 1 methyl group at 4th position. That is another isomer. This is 3, 3, 4 trimethyl hexane. I think we are exhausted with the methyl group as substituents. Now we have to use a combination. 1 ethyl and 1 methyl. That's how we have to write the isomers. And therefore, number 24, 1, 2, 3, 4, 5, 6. Let's put 1 ethyl group at 3rd position, 1 methyl group at 2nd position. As per alphabetical order, we have to mention the ethyl group first. And therefore, 3 ethyl, 2 methyl hexane. That is the correct IUPAC name. Not 2 methyl, 3 ethyl. That's not the way you should write. And then number 25, Let's keep the ethyl group where it is and move the methyl group also there. That is another isomer. This is 3-ethyl 3-methyl hexane. And then number 26. 1, 2, 3, 4, 5, 6. Let's keep the ethyl group where it is. That is at 3rd position. And then put one methyl group at 4th position. So this is 3-ethyl 4-methyl hexane. And then number 27. 1, 2, 3, 4, 5, 6. Let's move the ethyl group at 4th position. So this combination is 2, 4. But if you number it on the other way around, 1, 2, 3, 4, 5, 6, then it would become 3, 5. That is not the correct way of numbering. 2, 4. That is the correct way of numbering. And therefore, this is 4-ethyl 2-methyl, because once again alphabetical order comes into play. So 4-ethyl 2-methyl hexane. That is the correct IUPAC name in one line. By the way, no 4-ethyl 5-methyl is possible. So we are exhausted with the hexane chain. Therefore, let's move to pentane chain. Number 28. Let's write the pentane chain first. 1, 2, 3, 4, 5. We are going to use 4 methyl groups as substituents. And therefore, let us first write isomers of those. So 2 methyl substituents at 2 position, 2 methyl substituents at 3 position. So this is 2, 2, 3, 3 tetramethyl pentane. And then number 29. Let's keep both the methyl groups at 2nd position, but move one methyl group to the 4th position. So if we do that, then that is another isomer. So this is 2, 2, 3, 4 tetramethyl pentane. And then number 30. 1, 2, 3, 4, 5. Let's keep 2 methyl groups at 2 position and 2 methyl groups, let us put it at 4th position. That is another isomer. This is 2, 2, 4, 4 tetramethyl pentane. And then number 31. Let's write the parent chain and then put 2 methyl groups at 3rd position, 1 methyl group each at 2 and 4th position. So this is 2, 3, 3, 4 tetramethyl pentane. And then number 32. We are exhausted with the pentane isomers of those with the 4 different methyl substituents. Now what we are going to do is we are going to introduce 1 ethyl group and 2 methyl groups. Let's put the ethyl group at 3rd position and then 2 methyl groups at 2nd position. This is 3-ethyl, once again alphabetical order, 2, 2 dimethyl pentane. And then number 33. 1, 2, 3, 4, 5. Keep the ethyl group at 3rd position. Put one methyl group at 3rd position and one methyl group at 2nd position. That is another isomer. This is 3-ethyl 2, 3 dimethyl pentane. And then number 34. 1, 2, 3, 4, 5. Ethyl group at 3rd position. One methyl group at 2nd position. One methyl group at 4th position. So this is 3-ethyl 2, 4 dimethyl pentane. And then number 35. The last isomer. 1, 2, 3, 4, 5. We are going to put 2 ethyl groups at 3rd position. That is another isomer. So this is 3, 3 diethyl pentane. In total, we have written 35 isomers of C9H20 and their IUPAC names.